Hello everyone, so in this video I'd like to be showing you how we use some multimeters. We both have the Fluke 177 multimeter, the yellow one right here, and the red Amprobe 37XR-A. Now generally, as you can see, both multimeters have the same layout, almost the same buttons, but once you learn how to use one multimeter, you definitely know how to use any multimeter. But for now, we're going to just start off with the 177 Fluke. So as you can see, the 177 here has a display, has a set of buttons, and it has a set of symbols on a rotary dial, and each symbol here represents for a certain type of test we want to do or a certain setting we want to use for a particular type of measurement. Also at the bottom we have 4 terminals. Each terminal is used specifically for a particular measurement type. So we have a terminal that has a red label on it with white letters for measuring voltage, resistance, continuity, and diodes. And we also have a common, which is the one we always pair our red wire with. We have a 400 milliampere terminal for measuring current and a 10 ampere terminal for measuring current. Now, you will notice that in your kit you should have gotten these red probes. These are the probes that are used to connect to our multimeter. So obviously we have a red probe and a black probe. The red probes always connect in the points that have a red label on it, so that would be this one, the V, the ohm sign, and the diode, or we would connect it to the milliampere, 400 milliamperes, or the 10 ampere terminals. And the black probe will always go to the common, but I'll be showing you how to specifically measure voltage and current in a separate video. Now, as you can see, we have several settings on the multimeter. As you can see, it has a rotary dial and it's on the off position, so that's why we don't have anything displayed on the screen. Now, you will see in the symbol up here, it's a V with a little curved line. And the reason it's curved, it's representing AC voltage measurements. So once we have the rotary dial set to pointing to this symbol, we are ready to measure voltage. Now, just for example, if we did want to measure voltage, I would connect my probes to, I would connect my red probe to this terminal and my black probe to the common terminal. And then I'd be ready to measure voltage. But in this case, we're not measuring any AC voltages. So just like the same thing and the same configuration, if we wanted to go up to the next setting, this setting indicates that we're measuring DC voltages. And just to confirm that we're on the correct setting to measure DC voltages, you can see on the screen that it says DC. So we're ready to measure DC voltages. And the same terminals, the way we have it connected with our probes is just the same. We're always going to put our red probe in the red label that has the V to measure voltage, and the black probe on the common terminal. Now the next setting, it says MV, and the way and also you can notice it has a line dash and a dashes on it. So that's another way to know that we're on the DC setting for measuring voltages, and because DC is always constant, so that's why they have a line. Anyways, so the millivolt setting does have a range to it. It measures up to 600 millivolts, so you do have to take consideration of how much voltage you're measuring. So if you're measuring, let's say 700 millivolts, then you want to change to this other voltage setting. But if you're measuring any voltages lower than 600 millivolts, then you can definitely use this setting, the MV, or the millivolt setting. Moving onward to our next mode, we have the ohm and capacitance mode. So currently we are on the mode to measure resistance because we have the ohm symbol on the display. Now, if I do want to measure resistance on a resistor, I would just go ahead and put my probes across a resistor, which I already have on the breadboard, and I can see I got 9.93 kilo ohms. Now, the reason why they have two symbols is because we can switch between modes using the yellow button. So if I go ahead and push the yellow button, now you can see on display it changed from ohms to F, because now it's measuring capacitance, and we measure capacitance in farads. So we switched modes by pushing the yellow button. So now I have a capacitor right here on the breadboard, and I'm just going to go ahead and measure the capacitance across the capacitor. Now you can see we have 9 nanofarads on this capacitor. So we can just go ahead and switch between modes by pushing the yellow button. And you see I'm switching back and forth between measuring resistance to capacitance. Now the same follows for the last settings on the multimeter. So now the next setting is for measuring continuity. We still have our probes connected to the same terminals as we did before. So the continuity is used for checking components and usually for testing PCBs. Something we don't normally have to do in our class, but if I did want to test this function, the reason why it has those small bars is because it's showing that the multimeter is going to produce a noise to show that there's continuity. And one way to test this is to connect the leads together on the multimeter, and it should make a beep noise. And therefore it's proving that there's continuity between the 2 points on the probe. Now the next setting is a diode, and this setting is used for testing transistors to see which pins would provide you forward bias. So I have a transistor here on the breadboard, and I can go ahead and check the transistor to see which pins will give me forward bias voltage drop. And this is a way to know whether which pins are my collector, emitter, and base. So you can see I get the 0.7 voltage drop, or 0.69, which is about we approximated to 0.7 volts. So I'm getting my forward bias voltage drop, but if I reverse it, I don't get the forward bias voltage drop. So basically that's what it's for. Now you will see in the next settings, it says milliamperes and amperes. We do have our multimeters, the probes connected to the volt to measure voltage. So in order to use these last two settings, we do have to change our probes to other terminals. So I'm just going to go ahead and remove this probe from this terminal. And depending on how much current I'm going to be measuring, I need to connect it to the appropriate terminal. So if I wanted to measure current that was less than 400 milliamperes, then I would connect my probe to this terminal. But if I wanted to measure currents higher than 400 milliamperes or below 10 amperes, I would connect it to this terminal. So I'm just going to go ahead and connect it to the 10 amperes terminal. Now in this configuration of my probes, I am ready to measure current. Now you will see as well that these settings do have two modes to it. You see in white it has milliamperes, but with the white line to indicate that we're measuring alternating current, and in yellow the solid line with the dashes to measure DC current. And also to verify that we're in that mode is to look at the display, and you can see that we're in the AC mode for measuring current. Now if I just go ahead and push the button, you're going to see that it changes from AC to DC. Now we're ready to measure DC currents in the milliamperes range up to 400 milliamperes. And likewise, we can do it for the next setting. I'm currently in AC mode, and if I push the yellow button, it takes me to DC mode. Now that's all there is to explain about the Fluke multimeter, and I'll move on to the amp probe. So now we have here the amp probe 37XR-A multimeter. Now it does have the same layout, a rotary dial with several settings and multiple nodes per setting, and a yellow button to change between modes. So you do notice that we do have 4 terminals, and we always have a common on every single multimeter. The common is where the black probe goes, and the other terminals is where our red probe will go. Now you will have received this type of probes to go with this multimeter, and you do notice that there is a plastic on this end of the probes, but you can take it off, which will allow you to get into more tighter spaces when perhaps measuring voltages on IC pins. So if you need to, you can go ahead and unscrew those if you'd like. So just like in the previous video, we do want to connect our red probes. Also, they have these black covers, or these plastic covers to go on the probe. So just like in our previous video, we would connect our red probe to either this terminal to measure voltage, or on the milliamperes or microamperes terminal to measure current, and anything above 400 milliamperes range, we would connect it to the second ampere terminal or current terminal, and our black probe would always go to common. Now just to go over the settings that we have on this multimeter. As you can see, the first setting is to measure AC voltage. The second setting is to measure DC voltage, and you can confirm that by checking the display. We have DC voltage ready to go. It has a continuity and resistor mode. So currently we are in, as you can see here closely, we are in measuring resistance, and I'll go ahead and test that by measuring the resistance between the resistor. And we get 9.88 kilo ohms. And if we go ahead and push the yellow button, we should be in continuity mode. And if I go ahead and connect the probes together, we should hear a beep. Now this next mode, we are testing diodes and transistors for forward bias. So I'm just going to go ahead and test the transistor that we have here on the breadboard. And we get almost the 0.7 volt drop, or the forward bias voltage. The next setting is for checking logic levels. The next setting is for checking frequency. This next setting is for checking capacitance. So now I'm just going to measure the capacitance on the capacitor on this mode. However, we do need to pay attention to the terminals. As you can see that so far we've used to measure voltage, both AC and DC, resistance and continuity, and diodes when we had our red probe in this terminal. But now that we're measuring capacitance, we need to switch our probe to this terminal here. So I'm just going to go ahead and do that. Now I can measure capacitance. And you can see I'm getting about 9.09 nanovolts, similar to what we had on the Fluke. Now on the next setting is for measuring millihenries on an inductor, henries on an inductor, and the last settings are for measuring DC current. And as you can see, the primary mode is in DC, and the second mode, if I push the yellow button, we are in AC, and you can see how it switched from AC to DC, or DC to AC. So now I'm in DC, now I'm in AC. That's for measuring the microamperes, and as you will notice on this terminal, it's for measuring microamperes and milliamperes. So for the next setting, I wouldn't have to change my probe on the other terminal. I could keep it in the same one. So far that we've measured current, the microampere and the milliampere, we've had our probe connected to this terminal, which is designated for measuring milliamperes and 400 amperes with the limit up to 400 milliamperes max. If I were to change the dial to the next mode, the the multimeter is going to make a sound to alert me that I need to change the probes to the correct terminal. So I'm just going to go ahead and demonstrate that. It alerts me because it wants me to make sure that I'm not going to measure currents over 400 milliamperes on the incorrect terminal. Now, likewise for the 10 amperes, as soon as I connect this probe to the 10 amperes terminal, it's going to alert me the same way. And it can be corrected by changing the mode on the multimeter to the correct mode with the terminal. So generally, this multimeter functions the same way as a Fluke. There's just more modes or mode settings. And generally, if we want to alternate between modes, we can use the yellow button. So the last few things I'd like to go over on the multimeters is that they do have a stand which we can use to have them stand up while you're taking measurements. So they're found on the back and there's a flap. You just lift them up and they're ready to use while standing up. Another thing I want to point out is that you do not want to leave your multimeters on any mode after you're done using them, because they will use up the battery inside, and even though they will look like they're turned off, they're actually on standby power, so they are still using up that battery. So make sure every single time you're done using the multimeters, you put it on off. So another note I'd like to include is that, well, specifically for the Fluke 177, it's common that we wrap the probes around the multimeters. And one point I'd just like to make for the Flukes, because it's really difficult to remove the probes from the terminals, it's probably best just to leave them inside, just so that you don't have to keep unplugging them and plugging them back in. But the way I'd like you to wrap it is to orient the probes in this direction, so that the probes, when you wrap it, you're not causing any strain on the probes or in the terminals inside. So then, when they're oriented in this direction, you can just go ahead and wrap the cable like this. And as I said, the reason why I want you to orient the probes in this direction is so that we don't cause any strain. Now I'll just show you how the wrong way is. I would like you to not wrap the probes when they're oriented in this direction. It's going to cause strain, and it might cause some sort of disconnection inside. So just keep it the way I showed you the first time. Just like that. Now, although the amp probes are a little different, these terminals are not as difficult to remove the probes. So I'm just going to suggest that every time you're done using the probes or the multimeter, just remove the probes. The orientation on these terminals are a little wonky, so it doesn't really work out the same as wrapping the probes and the cables around the multimeter. So I'm just going to suggest to remove it every single time you're done using it, and just wrap it around your hand very simply and storing it like that. And that concludes our video on the multimeters. Thank you very much.